just preparing. Okay, I think we are live on YouTube now. Y'all should be able to see the okay, perfect. So our first talk of today is going to be by Spencer Kelley. We're just going to watch the slide live first, and Spencer will be present in the call to answer questions at the end of the talk, which is the last 15 minutes. If Spencer, you're here already, not sure if you're here already, but oh, hello.
Hello.
Welcome. So I'll just give a brief intro to Spencer, and then we could watch Spencer's video. So Spencer is the author of Compromise, a small natural language processing library for the browser. He's a web developer and maintainer of open source libraries. His background is in the semantic web and Wikipedia. Today, his work focuses on creating infographics. His open source work is funded by freelance web development, and he's from Toronto, Canada. Thank you for joining us, Spencer.
Thank you for having me. It's my first conference. It's great to be here.
Awesome. So just to read a brief blurb about the talk, Spencer sent this over to us. So the talk for today is on typing, historical, and potential interactions in word processing. So people love typing in a surprising and universal way. In this talk, Spencer will look at the development of word processing and the design decisions in this historic interface. Can NLP contribute to word processing without making it worse? What would a text-centered computer really look like? We look at the history of punctuation, keyboards, and markup languages. We look at Wikipedia, text editors, and data structures with the goal of authoring usable data in text. Thank you for your talk, Spencer. We can go ahead and start watching.
Hi, my name is Spencer Kelley. I'm the author of Compromise, which is a natural language processing toolkit. It's not the most clever or the fanciest, but it is the smallest, which means that it's actually small enough to go into a web page and parse text on key press. We've been working on this for about 6 years. There's 100 contributors to the project. We just had our 200th release, which means that we've had a release every 10 days for the past 6 years. Compromise is doing pretty well. It's running at the Guardian, United Nations, the NHS, a number of banks as well. So I hope to keep the pace up. The basic philosophy of the idea is that, well, accuracy is pretty nice. It's not as nice as customization and config. When something is as sensitive as the English language, people really care a lot about having not a black box, but in fact a customizable solution. If you're a web developer, you'll know this graph. File size is really important when it comes to the web and load speeds for browsers. Compromise is right in there, quite comfortable. I said it's not the fastest. It is quite fast. It's for most purposes, you can parse a Wikipedia article in about the same time as a human. So I am a believer in New Year's resolutions. This year I had all these ambitious plans.
Sorry, I think I just
want to describe in a positive way what my dream computer would look like. A few years ago, Jason Wan did this, Mercury-OS, which is really nice. It had this way of organizing the operating system instead of applications, but based on focus and workflow. There's also Desktop Neo, which had this idea of opening all windows to the right. So if you wanted to go back in time, you would scroll to the left. More recently, there's this VROS concept, which talked about a operating system that would be really usable in virtual reality. So what happened, though, is that the more I thought about this problem, the more I started thinking about my posture, and what it actually means to be good at a computer. And if I had a dream computer, wouldn't that just mean I was spending more time on it and my life was less healthy than it is? So these are the things I started to think about this year. At the time I was working at the startup where we had a stand-up meeting every day, and the product manager, she would open this application called Bear. And as we were going around the room talking about what we were doing, she would just type in real time, and she had all the keyboard shortcuts and things done perfectly. She was just an advanced user of this application. And it became actually quite mesmerizing to watch her use this thing. You know, it's a little bit like watching a figure skater where they're not scared about falling and they're not scared about what score they're gonna get. You know, they can just really lean into their routine. And it's a really nice way of working. And I started to think about what would that actually look like on a computer, you know? And is it the case that the text editor is actually the best interface, you know? Can anything really replace it? Or should it? What would a computer look like that was actually just driven by text? So those were the sort of things I was thinking about and what I want to talk about today. So I'll talk a little bit about compromise and the way people are using it and the application of it that I think are most interesting with regards to typing and text editors. Talk a little bit about keyboards and ergonomics, then go into punctuation and markup languages and the history of the sort of historical anecdotes of why we do things the way we do. Then I'll talk about text editors and the way we organize text in them. Finally, I have some demos about different interactions about refactoring using grammar and things like this. Okay, so if you haven't seen this, it's quite remarkable.
What are some of the needs that you believe that writers should be asking for in the next round of talks from producers?
Apple needs to fix those keyboards. They are impossible to write on. They've gotten worse. They makes me want to go back to PCs because PC keyboard, the bounce back on your fingers is way better. And hands up who still uses a PC. You know what I'm talking about. It's a way better keyboard. And those Apple keyboards are horrendous, especially as the computers, as the laptops get newer and newer. I mean, here's the latest new iMac. The keyboards are worse, and I've got some shoulder problems. I've got like a sort of OOS, what do you call it over here, like this sort of thing here, which is that tendon that goes from like the forearm down into the thumb. You know what I'm talking about. You guys are writing, and what happens is you open the laptop and you're like this. So the laptop, we've just got to fix those keyboards.
So M. Jackson is a big name in the JavaScript world, and he posted this tweet in 2019, and the results were exactly as you think they would be. It's remarkable, though, when you look at the usernames of these people, creating some of the most important software, running human society, yet their computers are wobbling around on pizza cartons and unread Bibles and things like this. It's not just the web developer community. This is Nikolai Budarin on the International Space Station, developing a repetitive strain injury, for some reason in a closet. But it just feels like something we have not taken seriously for a long time. Tony Abraham makes these concepts on YouTube where he, I don't know if desk is the right word, but he creates these workspaces based on with just scrap wood. He has some concepts where he's typing up like this, which I think are really neat. Zoe Smith, who I found on the Ergodox newsletter, they're a keyboard manufacturer, but they have this newsletter where they every month they interview a knowledge worker about what their desk is like and how their workflow is set up. And it's really, really interesting. She writes her software basically in a yoga pose all day long. And there's no reason why keyboards need to be on the desk in the first place. On the left is a concept from the movie Children of Men, which is inspired almost certainly by the septambic keyer by Steve Mann many decades earlier. You may have seen this blog post as well a few years ago. Stephen Wolfram not only takes his video conferences out on a walk, but he actually writes software while he's walking. He talks about he bought a strap.
Oops, technical difficulties. Sorry about that. We're trying to get a hold of the difficulty right now.
Okay, can we see the video now?
$1 billion computer manufacturer.
Let me just backtrack a little.
Septambic Keyer by Steve Mann, many decades earlier. You may have seen this blog post as well a few years ago. Stephen Wolfram not only takes his video conferences out on a walk, but he actually writes software while he's walking. He talks about he bought a strap from Amazon.com for $12, and it completely changed the way he uses a computer. There are now several $1 trillion computer manufacturers, yet a $12 strap will change the way you use one. So people hate their keyboards, but we have to acknowledge that people love typing. For some reason, that's almost mysterious. They seem magnetically drawn to the act of typing. If being a successful entrepreneur is the art of knowing when you have a good product, I think we in the NLP community need to acknowledge that people already love typing. We don't need to ask them to type. They just do it on their own. Not quite sure why, but it's a remarkable phenomenon. A lot of ink has been spilled about the command line and why we still use it. This is an example of a beautiful command line application. And ask yourself, when's the last time you've used an interface that's as immediate and as clear as this is? I love this example. Today, we romanticize typewriters a fair amount, but we need to acknowledge that people did not love typing when they had to use a typewriter. Nobody took the typewriter home for fun. Not only did they look like some sort of torture device, but they were loud, they were heavy, and worst of all is that when you made a mistake, you would need to start the page again. It was worse when you made a mistake at the bottom of the page, because you would lose a lot of work. I should mention that maybe the sort of undiagnosed domestic pain of using this thing really has led to the modern workforce, and in the ways that people are struggling in workplaces today. So in 1969, the IBM Selectric Magnetic came out, which was the same concept as a typewriter, where you strike a key and it lands on a page, but it also recorded your key on a magnetic tape, which you could remove and replay as well. It's a bit like a player piano, where you could press play and it would type for you, and then you could press pause and make an edit, and then press play again and do the rest of the document. If you're over the age of 30, you may know what this key is. This was the insert key, which produced the same sort of effect called overwrite mode. But one of the unintended consequences of this magnetic thing, you can feel that it was an early attempt at word processing. If you made a mistake, technically you could go back to the previous word and change it. But in practice, because you had to replay the document, what happened in effect was people made spam. It became really easy to do this instead of word processing. And this is something that never occurred to me, that the whole point of using a typewriter in the first place was to make a document look formal and official. And once people started being able to reproduce them really easily, it sort of dissolved the whole point of using a typewriter in the first place. So that's one of the early unintended consequences of information technology. This was something that occurred to me as well during this presentation. And maybe it was just because typewriters and computers are both using the same keyboard. It seemed obvious to me that they would eventually converge. On the left, you have the history of typewriters, which began sort of at the turn of the century. On the right, you had computers, which you could type into, but would concern themselves only with numbers. Well, typewriters were concerning themselves with entry in the display of text. So it wasn't until very late that this idea that they were both the same thing started to dawn on people at all. You could have started your career at the beginning of computer science, the first computers, and retired before you ever entered prose into a computer. It just wasn't something they did. Until this. This is called the mother of all demos in December 1968. Doug Engelbart and 13 others worked for 6 years on this demo. Their budget came from NASA and the United States military. And it gets a lot of credit for being the first use of the mouse. But I think the most important development of this demo was actually the idea of entering text, plain text, human prose into a computer. It was the first time, at least I think, that the mouse or the keyboard cursor appeared. You could go back and forth like this. Watching it now, it's a little bit of a weird demo, but it's exactly like when you play a early hip hop song for a child, and they say, "Oh, that's just a hip hop song," but you say, "No, that was the first one." This dawned on me when I saw this picture. This is the computer that they built it with. They had to build their own display. They built their own keyboard. They built this whole input-output system. They basically made it into a personal computer. And this certainly does not look like a personal computer. So Motherwell demos really was quite something. I should mention too, because I was complaining about ergonomics. One of the contributors to this demo was none other than Herman Miller, of the Herman Miller Chair Company. They had all these plans about putting the computer in the floor or the walls. They had demos where you would control the mouse cursor with your knees or your neck. But it was completely an accident that they ended up using what we call a modern keyboard setup today. I should mention too that when people talk about the history of engineering and the greatest engineering accomplishments ever, they often mention the personal computer and the Apollo program. If you realize that they actually happened at exactly the same time, these two pictures were taken on the same day as Apollo 8 was rolling out onto the launch pad and then launched people into the Earth's orbit for the first time. Sorry, the moon's orbit for the first time. So this interface was not at all an obvious choice. In fact, probably more obvious was this, which actually was working at the time. The light pen, if you wanted to enter things onto the screen, it makes perfect sense just to add things onto the screen. But what they found is that maybe it was because children were learning keyboarding in schools at the time. Just typewriters were a popular career choice. People just liked keyboards. They liked moving their fingers like that. And they didn't mind that there was this sort of disconnect between the keyboard and the screen. So I want to talk about these characters specifically. There are some punctuation characters that are obvious choices, the parentheses, the exclamation point, and stuff like that. Some of these characters are really funny choices, actually. And the reason why we're stuck with them, there's all these historical anecdotes. The tilde, for example, it first began its life as an overstrike character on typewriters, which meant that you would type a Roman N, or just an N on the keyboard, and then roll the carriage back and type a tilde, which placed the wavy line on the top. The tilde has since become the home directory in Unix systems. And if you're curious why, you just had the word home written on top of it on the Siegler keyboard. Now the tilde has come to represent in a cultural way, sort of approximately or almost equal. It's the same story for the @ symbol. In the early logs of the telegraph, they developed this shorthand for saying "at the rate of." A lot of it was commercial communication. So 5 shares at the rate of $3. That just came to be the squiggly A, which found its way on some typewriters for some reason. Ray Tomlinson, the creator of email, famously chose it as an email thing. And not to throw shade at email, but I think one of the reasons why it was successful was because it used a punctuation character that nobody else was using. So maybe we're, in some ways, we're sort of running out of punctuation, that we're stuck with this like multi-social use of each character. We have no pure control characters to speak to the keyboard anymore, to speak to the computer anymore. The same situation, especially now with the hashtag or the pound symbol. It was used for music and things, and then we adopted it for engineering purposes with comments. And now it's found its whole life of its own. exactly the same situation with the asterisks. You know, it used to be before typewriters, it was sort of a birth date symbol, like nay or born in. We started using it for multiplication in engineering, and now people use it as like a stage direction or like an action. So it feels like in computer science, we've been sort of pushed into this corner, you know? We've built this amazing empire of signs and symbols based on only these little characters. And I'm sure that in the future, they will be adopted for cultural reasons. You know, it's a little bit crazy that we use the same keyboard for engineering as we do for writing a novel or so forth. I'm particularly worried about this backslash character being adopted by like TikTokers or something like that, because backslash is used as a universal escape symbol. This is an SQL injection on a bumper sticker for license plate readers. SQL injections are this very common and pernicious type of security exploit that takes advantage of escaping. That is, your syntax has control characters. And then if you want to enter them, you escape them. And if you want to enter that, you escape the escaping, and then escape the escaping. It's a problem that we just encounter over and over and over in computer science. We can't solve it for some reason. Just this week in Britain, somebody registered a corporation, and the name of the corporation was a cross-site scripting attack. And from what I understand, they actually ran remote code in the corporate registrar in the government of Britain, in the UK. So this is happening every day, and it's just something we cannot solve for some reason. So we're in the situation where users, you know, want to type, and we want to get data from them. We want them to communicate with the computer. But it's like there's this bridge that we can't cross. And I'm not sure why. It seems like it should work, but we can't get it to work. If you've ever edited Wikipedia, you know that it's sort of the utopian dream of text as data, you know? Like we're all working on text together. But anybody involved with a Wikipedia project knows what kind of trouble it's in, particularly with the markup language. This is the first 3 sentences of the Albert Einstein Wikipedia page. Basically inscrutable and also unparsable, but I won't talk about that right now. So do we need a new keyboard? Do we need a new punctuation character? You know, I know there are all these Unicode characters that we could use, but it's not under our fingers. So it's almost not relevant to the problem. Maybe we need a new markup language. I really can't tell, you know? This is what's called the pro sign. Story of Morse code and how each letter was mapped to a particular dot and dash symbol. But few people realize that like in all software projects, Morse code was subject to this software bloat where people kept adding features. And what happened in Morse code is that if you type a number of sentences, you started to want a new line character.
Sorry, I just muted all.
So it was like a new line, you know, like immediately people started adding markup to their text or some kind of like metadata or something like that. Maybe there has been never pure plain text, you know? It's just something that we've always had the illusion of in computer science. I love this markup language. This was developed last year by Alex Gamberg. What's cool about it is that you can just type a paragraph, but as soon as you use the square brackets, it recognizes the indentation. So you can actually, when this parses, you can query things like what year was adaptation made. The New York Times has a very similar system. They had the problem where a journalist would create a web page and then they'd want to change some piece of information. And in order to do that, they would need to, you know, find a developer, tap them on the shoulder, say, hey, can you change this? And then they would check out the repo and commit, do the build, whatever. It was just this huge process. And so they said, wouldn't it be nice if journalists could just change the data? From what I understand, this markup language is actually quite successful inside the New York Times. 9 years ago for ACM conference, this demo was made called Glimpse. In some ways, it's a pessimistic idea in that it's suggesting that like all markup languages are going to be bad. You know, they're always going to be inscrutable and difficult to reason about. And all layouts are always going to be really different than the markup language. So what if we could just build this transition that made it seamless between them? I think it's a beautiful demo. I'll leave it there. So in some ways, we've been just struggling with this for a long time, since 1968. In some ways, we just can't get users to type data, and we can't parse what people type. It feels like we're going around in this loop where we start on the left-hand side with a series of commands or an API or something, and then users say, why is this so hard? Why do I have to read all those docs? And we say, okay, let's make an interface. So that's the red arrow. And then they say, oh, great, thank you for this interface, but I want to do this, this, and this. And so we have this blue arrow. Over the course of my career, I've been the red arrow, I've been the blue arrow, and I feel like it just goes around and around. Maybe the best place or the sweet spot of this is the pink area, where you're still typing, but you have these sort of micro interactions when you're typing. It's like a micro UI where like in the hashtag and the @mentions on Twitter have been really successful recently, but it seems to require this weird set of skills that very few people have. And very few people have actually pulled off doing it very well. These are the ones that I think have been great. So speaking at an NLP conference, one possible alternative to this is that we just developed this really clever NLP interface that you can just throw text at and it's going to understand somehow. I'm 34 now. I'm starting to think it's not going to happen in my lifetime, but I would love it if it did. So I've been watching this demo really carefully over the past few weeks. One thing that goes sort of unacknowledged about it is that I'm not sure about this, but I think that text at the time was represented as an array of arrays, or a two-dimensional grid of monospace characters. Correct me if I'm wrong. I would love to hear more about this, but I never saw any word wrap in the demo, which made me think that is actually like a spreadsheet. People talk about how we use spreadsheets all the time, but few people talk about text as being like a spreadsheet of characters. Text is not a spreadsheet of characters in many ways. One is this. Here. Maybe we should say that again, because it's very subtle and we use it every day and we don't acknowledge it. Right here. Word wrap is this really pernicious part of text that we use all the time and don't think about. And it actually introduces all these complexities into text. I took a short story by Edgar Allan Poe and I removed the new lines, and then I tried resizing the text area in Safari. You can see it really struggles. This is at a time, I have a MacBook and we're in 2020 and we can play, like first-person shooters in a browser, yet we struggle with a short story. If Edgar Allan Poe was alive today, maybe he would have to stick with paper and pen. So another way that text is different than a spreadsheet is that it's in overwrite mode, where if you were to change this E key, it would not shift all the other characters down, it would replace. Lastly, text is not, or at least in practice, users really do not like monospace fonts, especially now with emojis. Characters are all sorts of widths. And what happens, you can see, is that when you move the cursor up, where the cursor is going to be is really unpredictable. It does not count characters from the left, and you can see in modern software, it does not look as though it visually follows the XY axis at all. I think it's quite a broken system right now, and it seems to be getting worse. So yeah, text is not a spreadsheet. Text is not a two-dimensional grid. So what is it? And apparently, I read the Wikipedia page, and apparently it's supposed to be a splay tree. I did some graduate computer science. I learned about some trees. I don't remember them. I don't remember learning about this. I read this blog post that looked at all of the common text editors and what sort of data structures they use. and they all use different ones. I think this is the reason for a lot of the latency, a lot of the frustration that users have on computers today is this basic text editor data structure problem. It seems as though you need a PhD to do it. In fact, Ralph Levine does have a PhD and has been working on the next generation text editor for Google Fuchsia. I'm not sure where the project is right now, but he does have this great blog, which he calls Rope Science, which he talks about all the different ways that this problem becomes complicated, especially when there are more than one person editing the document at the same time, multiple cursors. There's also a lot of work going on with CRDTs right now, conflict-free replicated data types. This is a demo by Jared Forsyth, where he talks about what happens if you edit a document in the middle versus at the end. There's also like undo, which is a huge part of text editors, and it always seems to be bolted onto the end in an awkward way. I've been watching myself type a lot in the past few months, and what I found is that the actual typing is a solved problem. You know, it happens quite quickly. Today on the internet, you need to really carefully monitor your tone to avoid being misunderstood. I think most people, when they type, they spend most of their time actually just refactoring and refactoring their text to change how it feels. It's like the actual labor of typing seems to be this, and we have no interface sort of support for this. So I've been working on some demos with this with Compromise. They're sort of toy interfaces and sort of the common ways that I refactor text when I'm writing an email or something. The first one is this. There's an anaphora resolution, which is supposedly the easiest task in NLP. Just this idea that there are dependencies between sentences. And it'd be really nice if, we could see them and toggle them so you could flip between the anaphora and the referent. It's the same issue when you're reordering sentences, where I'm not sure if you would call them typos, but the issues from text that people have when writing text often come from just this moving a sentence and then failing to see that there are dependents between the sentences. So that'd be great if it highlighted them or even if it fixed them, and Compromise is able to do both. One thing that's really strong right now is number parsing and number generation. That's something that just is a solved problem right now in Compromise. It even does things like if the number is 1, it will inflect the noun. So it supports that pretty well. And it's nice being able just to type and then being able to change the number without having to type again. Same with dates. We were working really hard on date parsing this year in particular. And being able to change a date like this without having to edit the text is really quite nice. The most important part of editing text, or at least for tone and feeling, is adding a modal verb in front of a normal verb. And what happens though if you have to conjugate the verb into infinitive form? So this demo, we just find that way, like the connection between the modal and the verb, and we flip it when we recognize what they're doing. I'm not sure if this works, but it's sort of illustrating an idea. Okay, last thing I'll say about with this presentation, with me using a keyboard, I think the most frustrating part and the thing that few people realize or talk about is keyboard focus. When you press a key on a keyboard, it's not totally clear what application it's going to go to right now. And it seems like a small issue until you're Sean Spicer and you accidentally paste your password into Twitter twice. But you hear a lot of these horror stories about people pressing Control-V and not realizing where the text is going to go to. It's a little bit like these video games, where you can interact with some things in the world and not others. So what happens is that you end up just going around the room, walking up to things and seeing if you can interact with them. In the early days of the web, there were these ideas that all text should be editable instead of just this small rectangles which you're allowed to type into. But anyway, I think it's just a awkward part of operating systems right now. Specifically, this is my pet peeve with browsers. When you enter a website and press enter, and the web page loads, it's like at that moment, it's as if somebody has cut the cord on your keyboard. And if you start typing, it does nothing. It's like it's a dead interface. I've talked to some engineers at Mozilla about trying to get the browser to retain the keyboard focus if the web page doesn't require it. It feels like just a broken thing right now. Jeff Raskin had this cool idea in his Canon Cat computer, where even if the computer was off, you could just walk up to it and start typing. And it would remember what you typed while it was booting up. And then it would find a text editor and put it under it. As you were typing, it was like, okay, you're typing now. Let's let you type, which I think is a cool idea. Another good interface was in Quake in 1996, which people still talk about, in the Unix community and things like this. They had a terminal that would drop down from a keystroke, and you could type into it. And then when you're done, the terminal would pop back up and you can continue playing your game. It was just a great interface, people still talk about it. So in summary, we're in this situation right now with typing where we have all this historical baggage or technical debt from typewriters. And these design decisions made in 1968 have put us in the situation where we have this hard time understanding users and interacting with them in this seamless way. So my name is Spencer Kelley. I'm in Toronto if anybody wants to get a coffee or a beer after the pandemic is over. I insist that Compromise is a really fun project and welcoming to everybody. We're working in earnest this year on a French language version, which would require a lot of help. So I welcome everybody to join. Thank you very much.
Oh, thank you. So I think that's the live stream of the talk, and this is really interesting. I think from an NLP perspective, this is some things that we overlook most of the time, how texts are input, how differently people actually act in typing as well as speaking, as well as just like before typewriters. So is Spencer around?
Yeah, I'm here. Thank you.
So the floor is open. You can ask any questions, and yeah, anyone have any questions? No questions? Then I can start with one. So I have a question on autocomplete. Like, how do we really interact with autocomplete? And in the past, only programmers will interact with autocomplete because we type things that are kind of structured. But today you have those NLP models that can generate text even when you're typing an email. Like, what do you think like is the future? Are we going to just tap and let the model fill in the blanks?
Right. Yeah. Well, that's it. Like in Chinese input, that's notoriously, like there's huge amount of engineering gone into supporting languages that have too many characters for a keyboard. But I should say in languages that don't have that problem, I hate autocomplete. I think it's really, really serious problem. It's like the French Institute has this crazy, I should say crazy, but like very strict idea about what words are allowed and what aren't. It's like a like George Orwell sort of approach to language, and that's just not how language works. So I think that having like a blacklist, whitelist sort of thing for language is not the right way. And maybe this is a criticism of where we are in NLP right now. We're not very good at it. Like people are very frustrated with it. We're not good at understanding the first part of a sentence and predicting the second part. So I think we should roll back, like especially for interactions that don't inform the user that something is changing in their text. Like I think that's especially pernicious.
Cool. Okay, there's a question. Do you feel typing is really adopted by most users, or does voice-based interaction will be more dominant? Oh yeah, voice-based interaction versus typing.
Yeah, but I don't have any strong opinions about voice-based interactions. I had a repetitive strain injury when I was in my 20s, and I tried a bunch of tools, like sort of Linux stuff, and nothing was very good. And I eventually just had to start typing again. And there's I'm not gonna remember the name of the presenter. There was a talk about someone who was programming with voice interactions exclusively and became very, very good at it. It's quite compelling. I can share it in the comments after. But no, I don't have any strong opinions about that at all. Do you?
Me, I work for a company that owns voice-based stuff.
Right. Okay.
Yeah, but I think they are kind of crazy. Like sometimes when you talk about let's say Alexa, we were just in a meeting talking about Alexa, and Alexa just appeared behind. Something like this is kind of strange. Is listening to you, but whether it's taking in the input directly or trying to understand it before trying to do something, that's something that we didn't consider, because like when we type, we know what we are typing and it's shown, then we execute a command. But in these voice-based things, there's actually a model in between the interaction, right? What they're listening to, it's not actually something that's text or language, it's just sound signals. It could have been a car going through. So I'm not sure like whether it's really language that the voice-based stuff is based on, as much as like signal processing. And yeah, that's my view. I have no strong feeling like how will we move, but yeah. Good.
There is some with like the idea of sending every signal to a backend server that processes it. It's a data warehouse. It's quite scary, you know. Like there's police records that are being requested for like unintentionally sent noises. With Compromise, one thing that's happened that's been interesting is because it runs on the client side. There have been security. I spoke to somebody who worked at quite a major bank and wanted to do NLP, but they knew that if they had to do it on the server side, they would need to provision this whole server, and it would be like months of bureaucracy and stuff. So they ended up using Compromise, which is not the best a solution for like serious security conscious NLP, but they ended up using it because it can run on the client side. You know, they can just do all the processing right there in the browser, and so there's no security concern. You know, it's just running in their browser. So maybe the same thing with voice. Like if our models are really small or like able to run on the client, not send it back to Amazon, that may be a way more effective way, and like will improve the trust situation with users.
Yeah, I think that's the direction that everyone is heading. Our models are getting smaller, hopefully small enough to put onto phones and on the device, so that it's kind of privacy concern it's addressed. Okay, let's move on to the next question. How do you break down support for a new language? Where do you start? Do you mean by Compromise, or is Louis there?
Sorry, I missed the question. Break down the.
Yeah. I meant you. It was just to kind of pick up on what you said on supporting French and what you were looking at for Compromise. Like, how do you break down the support for a new language? Do you look at feature by feature, or like, you know, training like a new model for each language, or how do you organize that effort of supporting a new language for Compromise?
Yeah, that's a great question, Louis. I've been I'm in Canada, so I like everybody has a partial support for French, like a high school version of French. The most important thing with Compromise is that it just needs to be really small. And so the way that it's small is that it conjugates verbs in English. So we only store one form of the verb, and then we splash out all the forms we can. So we have this big lexicon with a small data set. That needs to happen for any language, I think. So I've been looking at conjugating verbs in French, which is of course way more complicated. There's also like gender with adjectives and stuff. So that's the first step. It has to be the first step. Like I know it's a very complicated thing to go between languages, but I think that conjugation between different forms is something that needs to happen first. And I've just been looking at, you know, the regular data sets and training like regular expressions and stuff like that. There's no fancy stuff going on, but that's where we're at right now.
So I guess that's the answer to the next question, where it's Compromise rule-based.
Yes, it is. Yeah, it started actually, we're using the Braille tagger, which is like the notorious rule-based one. And I just started adding features, and that's how it started.
Oh, by the way, my first project in NLP was the Braille tagger. It was really fun. And if you are new to NLP and you have not heard of Braille tagger, take a look at it. It's kind of like retrospective. Some of these things that we're doing in NLP, we're trying to add back the rules to these neural models, where the Braille tagger, it's kind of an inspiration to do this most of the time. If you look back, it is actually just trying to fit in and learn kind of a new rule based on a set of rules. So yeah, that's an interesting, yeah, it's good to know that it came from, it's inspired by the Braille tagger.
Yeah, and if there's a really compact neural net, what would it be other than just a rule-based, like I'm sure you could learn the Braille rules with a sophisticated neural net if you were so inclined.
Yep, that would be a good idea for a new project. So if you have this idea and want to implement, come talk to me. I like this. Okay, any more questions that we have for Kelly, Spencer? Does compromise work only in browsers? I see it's an NPM package. I'm not a user of Node.js. I'm not sure how can it be used by end users.
Yeah, that's the nice thing about JavaScript. A lot of people, when they hear that you're doing NLP in JavaScript, they roll their eyes. But one nice thing is that it can run on the server and client transparently. That's just a one-liner to do that. And I think most, or at least of the work I've picked up, most of it is on the server side.
I guess in NLP, currently many people are using Python. One flaw of Python is, in order to use Python on the client side, you must install interpreter, and this is a prerequisite, which in JavaScript, you just open up the script, run it on a browser, it works. So that's the nice part of that. And everybody have a browser, but not everybody have a Python interpreter in their machine.
Right. There's some work changing that. Like the WebAssembly world is really interesting, and I think if not next year, in 2 years, 3 years, we'll be running all sorts of languages on the client side. So that there's a lot of optimism there.
Yeah. Is there any more questions? If there's no more questions, then yeah, maybe I'll give the time back to Gitika and she can talk about some logistics, as well as thank you so much for being here, Spencer. I think this is a great different perspective of language processing and text processing that mostly researchers don't look into, how we interact with the text. And actually, this is the root of our data, right? Whatever data we have to train our models or any other tools that we build, the data itself, sometimes we really overlook how it's input. Cool, thank you so much.
Thank you, though.
Awesome. Thank you so much for joining us. I'm just going to stop the live sharing on YouTube, and in case people have any further questions about logistics,